The problem I had the most trouble on in test 2 is problem 2. So I'm going to go over how to solve that. So this problem is a solid sphere of radius r2 with charge positive q, which is inside a spherical shell with radius r1 that's charged negative q. And the charges for the solid sphere are distributed evenly, and the charges on the spherical shell are also distributed evenly. So part A asks to find the electric potential at point VA, at point A, which is basically asking VA minus V infinity, but V infinity is 0. So it's just VA equals V of positive Q times R1 plus V of negative Q times R1, which equals 1 over 4 pi epsilon naught Q over R1 plus 1 over 4 pi epsilon naught negative Q over R1. And these will obviously cancel out, making VA equal to 0. So next, part B is asking, point B is just outside the solid sphere, so it's asking what is the potential difference between VB and VA. But we know that, so since A to B is inside the negative sphere, the negatively charged sphere, then we know that only the positive Q charge contributes. So that means that VB minus VA equals V positive Q R2 minus V positive Q R1, which is 1 over 4 pi epsilon naught Q over R2 minus 1 over 4 pi epsilon naught Q over R1, which can simplify to VB minus VA equals Q over 4 pi epsilon naught 1 over R2 minus 1 over R1. And then lastly, part C is asking for, states that point C is at the center of the solid sphere, and is asking for the potential difference between VC minus VB, and it gives us that the magnitude of the electric field inside the sphere and a distance r from the center is E equals 1 over 4 pi epsilon naught QR over R2 cubed times R hat. So from that, we say that E of R equals 1 over 4 pi epsilon naught QR over R2 cubed R hat. And so VC minus VB equals negative value from B to C of E of R dot dP, where we can say dP equals dr r hat. So now we have this equals negative integral from R2 to 0 of 1 over 4 pi epsilon naught Q over R2 cubed of R dot dr, r hat times dr. So this equals, after valuing that integral, we get negative Q over 4 pi epsilon naught R2 cubed, and then we evaluate 1/2 R squared from 0 to R2. So then finally, after computing that, we get VC minus VB, so the potential difference between B and C equals Q over 8 pi epsilon naught R squared. So in order to practice more, you can change the problem so that the signs of the charges are different. You could also make them not be point charges to evaluate different uh, electric potentials, and also you could evaluate the potential difference at different and more locations.